All right, should say recording in progress. So we're doing chapter 1. And we're doing section 1.1 in the book. So natural numbers. Natural numbers are counting numbers. They start with the number 1, 2, right? 3. And they keep going, dot, 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 all the way to positive infinity. Positive infinity means that they don't stop. It just keeps going and going and going. This is natural numbers. Now, let's talk about integers. Now, for integers, we have negative numbers. So let's say -3, -2, -1, 0, 1, 2, 3, 4. So as you can see, there is a big difference between integers and natural numbers. Now, what is the difference between natural numbers and integers?
The integer says negative numbers, that is minus.
Right. Thank you. And it includes what other value? That big fat donut. What's that donut? What's
0.
Yes, thank you so much. Who was that? Mazreha. I hope I pronounced it correctly. I apologize. So yes, integers includes 0 and negatives, including natural numbers. So now let's talk about rational numbers. Now, the word rational comes from the word fraction. It's like saying, here in America, when we put gasoline in our car, we call it gas, right? Gasoline, gas. How many of you own a car? You guys own a car? No? Yes? Maybe?
No.
Yeah.
No?
Yeah.
Yeah, some of you. Okay, cool. That's nice. Those cars, some of them are electric, but the majority are run on gasoline, right? Now, in America, we call it gasoline, gas, right? But if you go to England or you go to another country besides the US, they don't call it gasoline. What do they call it? What do they call it?
Petrol.
What?
Petrol.
Petrol, right?
Yes.
I remember when I was in India and when I was in England, they looked at me funny because I'm like, you got any gas? And they're like, gas? We don't sell gas here. And they're like, yeah, you do. It's like, no, it's petrol. So it's the same thing here with rational numbers. Rational numbers are the same thing as fractions. So if you hear the word rational, is the same thing as a fraction. So what are some fractions? Well, we have a half, right? We have 3/4. We have a quarter, right? All of these are fractions, right? Who disagrees with that? What about 5? Can 5 be a fraction?
No.
Jada, can I turn a 5 to 5/1?
No.
Yes.
Can O.
Yes, you can. You could turn a 5 to 5/1. It's like saying Jada now becomes a fraction. Jada over 1. This is valid. So be on the lookout for that. Okay?
But I I thought you could your numerator couldn't be more than your denominator.
I'm always putting it over 1, so I'm not changing the value. Like
Okay.
if I put Jada over 3, then that's different, right? That's different, right? That's totally different. But I'm not doing that. I'm putting your name over 1. Or I'm taking the 5 and I'm putting it over 1. I am not changing the value of 5. I'm not changing it at all. And I can turn a fraction into a whole number, right? In this case, which is 5. Just remember that. Just remember that. All right, let's keep going. All right, next. Irrational numbers. Thank you for participating, Jada. Irrational numbers. So an irrational number is one that cannot be expressed as a fraction and it doesn't have repeating decimals, right? So an example of this could be pi. Does everyone know the value of pi?
3.14.
3.1416.
Ooh, you guys are good. I like that. 3.14, yes. Dot, 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 dot. What about the square root of 2?
Root 2.
Now,
1.
if you're able to use calculators in class and on the exam, but it has to be a specific type of calculator. It is a scientific calculator. You are not, and I repeat, you are not allowed to use graphing calculators. If you have a TI-83, a TI-85, a TI-89, or any type of graphing calculator, you are not permitted to bring to class. So let me show you. This is a good time to segue into this. And I'm going to show you the calculator that you could use. I'm going to show you right now. So let's take a look at the calculator that we could use. There you go. Hope everybody can see my screen. There you go. Now, if you look at the syllabus says that we can use a specific calculator. Should be here. Right here.
T. Wait a minute, I will take pictures.
TI-30XS. Does it have to be that one? No. You could use any type of calculator so long as it is not a graphing calculator. Please do not spend $50 on a calculator. Okay? These calculators are cheap. You could get them cheaper. I'm going to show you one that's $13 right here. See it?
Yes, we can see it.
You could get it in blue. You could get it in black. You could get it in pink. You could get it purple, gray. Pick your color. Now, does it have to be a Texas Instrument scientific calculator? No. You could use any scientific calculator. 1 second. But I got to tell you, I am not going to teach you how to use a calculator. That is your responsibility. So on the exam, if you're asking me, how do I find the square root of this on this calculator? What is the command? What do you think my answer is going to be?
I don't know.
Exactly.
Figure it out.
I have no idea because everybody buys different calculators. I might be able to help you with this one, but that is not guaranteed. So I rather you learn how to use it. Don't come on the day of the exam asking how to use it. If you need instructions on how to use a calculator, there is a wonderful resource that you can use, and it's called YouTube. And I use it for everything. I call this free university. And then here, you're going to put in how to use, and then you put the model number of your calculator. This is on YouTube. And if you need to learn how to get the square root of something, you could look at these videos. Okay? YouTube is wonderful. All right. So let's go back to my iPad. All right, cool. So an example of an irrational number would be pi or the square root of 2. If I do the square root of 2 on a calculator, I'm going to get 1.414213562. Are any of these numbers repeating themselves? Like in the sense of a sequence, like 4141 or 41424142? No, right? So that's what that means when it comes to irrational numbers. All right, let's go. What section in the book are we going to be focusing on for this? What's the section I said?
1.1.
First section.
Chapter 1, section 1.1, correct? Thank you so much. So that leaves us with the last section, not the last section, but the last example of real numbers. 1 second. I'm going to share a clip. And then I'm going to ask, what does that have to do with the math? Are you guys able to see what I'm seeing?
Yeah.
Wonderful. Let me know if you can hear the audio. 1 second. Okay. I bet you didn't think you were going to go to the movies today. So, let me introduce the next example. Not real numbers. What does Darth Vader, Yoda, Barbie, Optimus Prime, Wolverine, Thanos, My Little Pony and Garbage Pail Kids have to do with not real numbers?
Like it don't exist?
They don't exist.
There.
It doesn't exist. We have something called an imaginary number, but it's not a real number. And the reason why we call them imaginary numbers is because they live in the world of Alice in Wonderland. They don't exist in the real world, right? And something that is not real, we describe as a radical sign with a negative value. Let me repeat that again. Square root with a -1 is equal to Darth Vader. Does not exist. It's an imaginary number. Are we clear on this? Yes? No? Maybe?
Yeah.
Could be?
Yes.
All right.
Yes.
All right. That's what I want to hear. I want to hear. All right. So now let's review. You're going to be like, what? What do you mean, mister? What do you mean? What do you mean? We just touched on one thing. Like, how is it that we're reviewing already? That's how cool this class is. We review immediately. So now, I'm going to ask some questions. Which of the following are considered rational numbers? Which is a rational number?
3/4.
16.
Yes.
3/4.
Correct. Next. Which are considered integers? Which are considered integers?
0 and -5.
Yeah,
Zero.
0, -5. 0
Good.
and -5.
Next. Which are natural numbers?
3.
Okay. Anything else?
0, 3.
0.
Some of you are saying 0. Is 0 included in the list of natural numbers?
No.
No.
Do not pick 0. Do not pick a negative number because 0 and negative numbers belong to which group?
Integers.
That's right.
Wait, how you say that word?
Integers.
Okay, I said it right. Okay.
So integers include 0, -5, and natural numbers. But natural numbers do not have negative values and do not include 0. Okay? You will see this next week on Wednesday. And if you're watching this video later on, I am talking to you after the video is played. Do not select a negative value and a 0 for a natural number. All right, cool. Next. Give an example of an irrational number. Give an example of an irrational number. Give an example of an irrational number. Anybody?
Is that like pi?
Yeah,
I don't know how to say it. So it's pi
it is
3.
pie.
Yeah, pi
And I
3
love
maybe.
I love apple pie, blueberry pie, cherry pie. Yes, it is pie.
Okay,
What's
so
another example? You only need one, but let's say, you know, you want to be safe. What's another example of an irrational number?
Square root of 2.
Who said what, where, and when? You're breaking up. What's the number? Nobody?
The square root of 2.
Yes, Jada. Very nice.
That was me breaking up, by the way.
Okay, Jada, you're good. You could always use the chat if you're having difficulty. All right, good. All right, so let's keep going. All right. Not real.
Square root -1. -3. Square root
yes,
-3.
square root. No.
So
1/0.
which one is not real? Which is Darth Vader? Which is Barbie here?
The square root -3.
Okay. Is that it?
Um, Wait, is the not real numbers only negative or is it also positive?
It could mean that it doesn't exist besides
So
not,
square root 16.
well, this exists, this becomes positive -4.
What about 1/0?
Yes, this is undefined.
Oh,
If you see a fraction with a denominator with a 0, it doesn't exist.
okay.
If you see something like this, does this exist?
Yes,
This is a yes. This is okay. So
that's rational numbers, right?
yeah, that could be irrational. Yeah. Yep. All right.
Wait, I'm sorry. Can you just explain it one more time? Just the last part.
If you have a
With the
0 in the denominator, if you have a 0 in the denominator, you don't exist. If you have a 0 in the numerator, you do exist. Okay?
Okay, thank you.
All right, no problem. Alrighty. Then, so let's take a look here. All right, so let me do a little recap here on the top. For those of you who are looking at the video afterwards, we are doing chapter 1, section 1.1. Please, please, please focus on these things. Next, we are moving to chapter 1, section 1.2. All right, now, let me go to the book so everybody sees where I'm at. Because this is like show and tell, right? This is elementary school kind of stuff. I love it. You keep it simple, you get better results. Share. What am I sharing? I'm sharing my screen. There you go. All right, so you should all see that. No, maybe. Let me try again. There you go. I think you're able to see it now, right? Cool. So section 1.1 in the book, we just did. This talks about real numbers, right? Now, I want to be very clear, right? I like to be clear. Please be mindful that I am your tour guide. How many of you gone on a trip or a vacation and you have a tour guide? None of you go on vacation? You workaholics? You can't say you work more than me. Really? None of you go on vacation?
Nah,
Nah. So
nah.
nobody's been on
I
vacation.
don't use a
Nobody had
tour
a tour
guide
guide?
though.
Huh?
I don't use a tour guide.
You don't use tour guides?
No,
You like
Yeah,
getting
me
lost?
either.
I don't get lost. You just gotta wing it. You have the
You
best
gotta
fun.
wing it. You gotta hustle.
Yep, you have the best fun.
You got the best fun when you're lost.
Hell yeah.
All right. That's a valid point. Me, when I go on a trip, I like everything pre-programmed. I don't want to deal with no drama. I like everything nice and clear. So I am your tour guide in this quest of math. And I'll give you an analogy. When someone comes to New York City, what is the number one park they should visit in New York City? If they don't go to this park, they didn't come to New York City.
Central Park.
That's right. I'm not saying, and I'm not knocking the other parks. You know, there's Cunningham Park, there's Flushing Meadows Park, you know, there's Casena Park, there's parks in Brooklyn, parks in the Bronx, there's parks in all 5 boroughs. But the number one park in New York City is Central Park. So on the exam on Wednesday, they are not going to be asking you questions on parks other than Central Park. So you don't want to waste your time and energy looking at this chapter, section 1.1, and trying to cram everything in section 1.1. I want you to focus exactly on what's on this video. Yes, there are other materials that you can read, but you're going to do that on your own. You're going to become Jada on your own trip. You're going to hustle and you're going to go on your own, but not for this exam. For this exam, you're going to focus on the video. Are we clear? Yes? No?
Yes, clear.
Yep.
I don't want to get an email or a text saying, I'm doing this problem on the book and I'm getting lost because you didn't go over it. You know what I'm going to tell you? There's a reason why I didn't go over it, because it's not on the test. So focus on the examples that are similar to the ones I give you. Okay? All right, cool. So now let's get into section 1.2, which is exponents. All right. Here for exponents, we're going to learn about the base. We're going to learn about the powers. We're going to learn about the rules of the base when they're the same, and what we do with the powers. What happens when these bases are different, right? As far as their operation and all that good stuff. So I'm going to go back so everybody knows where I'm at, right? Chapter 1, section 1.2. All right, let's go back to the iPad. All right, cool. So remember this. You have a base. Okay? B for base. So you have a base that is raised to a power. This is the power. We also call this an exponent. And you have different powers and you have different exponents. You're gonna have it could be 0, it could be 1, it could be 2, it could be 3, it could be a negative value. Okay? Depending on that value, you're gonna do different things to it. All right, so let's go. Let's give some examples. So if I have a base raised to 0, it's going to be 1. So I'll give you an example. 2 to the 0. What's my base?
2.
2. My power is 0. 2 to the 0 is 1. Elena to the 0 is what, Elena?
Elena.
No. 1.
1.
Oh, one. Oh, 1.
What is Elena to the first power? That will give you back Elena. Notice the difference. Anything to the 0 power is what? Annette.
1.
1. That's right. Now, if I have 2 to the 1, well, that's going to give me 2. If I have 2 to the second power, what that is telling you here is you have how many 2's do you have? You have 2 2's, right? 2 to the 1, 2 to the 1, 2 times 2 is 4.
4.
So 2 to the second power is 4. 2 to the third, how many 2's do I have?
3.
3.
That's right. 2 to the 1 times 2 to the 1 times 2 to the 1. That is equal to 2 to the 3, which is the same thing as 8. Look at what I'm doing with the powers. 1 and
2
1
cube is equal
and
to
1.
8.
I am adding them, right?
Right.
When I am multiplying bases and they have the same base, I am adding the powers. Are we clear on this? Remember this. Okay? So, that's one. Next. When I have, so we already learned about the power of 0. We learned about the power of 1. We learned about power of 2. What about the negative? Well, what happens when we have a negative? What do you think is going to happen? What do you think is going to happen when I have that? Anybody remember what happens when you have a negative power? Nobody remembers when you have negative powers?
Do you subtract it?
Let's say I have b.
Or do you divide it?
B to the negative 1 or 2 to the negative 1. I have to do the reciprocal. Let me write that down. Reciprocal. Okay? When I am doing the reciprocal, I have to turn it into a positive. So how do I do that? How do I do that into a positive? If I am doing the reciprocal. Well, if
1
I'm
over
doing
2.
1, right, correct. So 2 to the negative 1, I am going to put a 1 here. And I am going to put this where? Where am I going to put this? I am going to put it in the denominator.
2.
I'm going to move it over here. And then this is going to become 2 to the positive 1. And I want to show you why that happens. Look, 2 to the negative 1. If I put it into a fraction, right? This division sign here is a negative. So a negative and a negative is what?
Positive.
Positive. So it becomes 2 positive 1. Because the division sign is a negative. These are things the book doesn't explain to you, but I am. So 2 to the negative 1, when I put it over a fraction, it's like saying a negative times a negative, right? It becomes what? A positive. And this becomes a 2. That's my final answer. When we just do it automatically, we're just saying, okay, 2 to the negative 2. Okay, that means that I'm going to put 1 over 2 to the positive 2. And people do it automatically. And they don't understand why this is happening, right? It's like when you're doing mofongo. It's like, it tastes good, but they don't explain to you how the mofongo is being made. You know what I'm saying? It's a process. So it's the same thing here. It's a process. People just buy it. And if you don't know mofongo, you better look it up. So 2 to the negative 2 becomes a positive 2, but it's in the reciprocal. Okay? I'm showing you the rules. All right, cool. Let's do some examples. I like the examples the book has for this section. So we're going to do some of those. Oh, the other one I want to do is,
Excuse me, sir.
yes.
Can you hold for a second? I go to washroom.
If you go to the restroom, it's fine. This is getting recorded. So you can walk away and it's fine because it's getting recorded. You're going to be able to see it later. Thank you for being so honest. All right, cool. Let's keep moving. So what happens? What happens if I have, let's say, 3 to the second times 3 to the third? What's happening here? What am I going to do here? Anybody want to tell me?
I don't know, but
Add
I'll
the
take a guess.
powers, so 2 plus 3.
Yeah. The first thing you got to do is, do I have the same base? Are the bases the same? Do I have 3 and 3?
Yeah.
No.
Yes.
Oh,
I
the
have the same
base. Okay.
base. Look, this is the same base. If I have the same base, what can I do with the powers?
Add them.
I can add them. So then this is going to become 3 to the 5th power. What is 3 to the 5th power? Well, what that means is 3 times 3 times 3 times 3 times 3, right? 3 times 3 is 9. 9 times this is 27. 27 times this is what? 1. 3 times 2 is 6, 7, 81. And then 3 times 81, that's 3 to 41. Right? No, 3 times 1 is 3, 243. 3 times 1 is 3. Yeah, 243. Let me see if I'm right. 3 times 3 times 3 times 3 times 3. 243, yeah, right. Okay, good. So if I have the same base, I can add the powers. So that's good. No problemo. What happens if, let's say, I have 3 to the second times 3 to the negative 3? What am I going to do here? Do I have the same base?
You're gonna, yeah.
Okay, I'm going to keep the base. Then, look what I'm going to do here. Look at what I'm going to do here. Look. Look at what I'm doing. Oops, too many threes. So what just happened here? Well, 2 plus -3. How many of you owe money to the credit cards? I'm guilty. I owe money to the credit cards. If you owe somebody $3 and you pay them back $2, how much money do you owe them?
That's one.
You owe them 1, right? But it's a negative 1,
Yes.
right? So I'm going to keep
Yes.
the same base and then 3 to the -1. What did I say about having a negative power?
Put 1 at the top.
Yes.
Put it over, under 1. Yeah.
So 3 to the -1 is the same thing as 1/3, right? You guys agree?
Yes.
Absolutely. So when you see a problem like this is what you are expected to do. Because we got to learn the rules of exponents. Now, let's keep going. This is not going to stay this easy. So we did multiplication, right? So let me write that here. The above is multiplication of what? Bases with powers, right? That's the above, right? We did that. Below, which is down here, we're going to talk about division of bases with powers. Now, let's say I have h to the 3 over h to the 5th. Do I have the same base?
Yeah.
I do. I want you to focus on the following. I have a power and I have a power. But I also have a division sign. What did I say about division signs?
It's a negative.
It's a negative. I'm going to
You're
write
going
it
to
here.
subtract them?
We're going to about to do that. So let's do it. So I have h to the 3, right? That's this over here. Then I have a negative. Then I have what? What do I have? I have a 5, right?
All right.
So what is 3 minus 5?
-2.
-2. What did we just say about negative values? We do what to
Reciprocal.
negative values? We do the reciprocal. So it's 1 over what?
2.
H
1 over h.
plus
2.
2. This is my final answer. All right, let's keep going. Because this I'm not even to the point of where I need to be. Okay, so next we are going to talk about, see if I can put this here. One second.
A slow mac drags you down.
Sorry.
Clean My Mac speeds things up so you stay in the flow. Your Mac holds your world. Clean My Mac keeps it tidy.
If you're building something real, people should be able to tell. That's why we built free identity services, not as a trial or a promotion, but as a better way to Dinosaur power!
Okay. So as you can see, I have no time because I'm always watching, I guess, these crazy shows, right? So what does that have to do with the next topic about exponents? This is called the product rule of exponents. Hence, go Power Rangers, Megazord, product rule of exponents. Please don't forget the Power Ranger in here. And what this means is we are going to distribute this power. You see that power outside? The 3? Someone say yes.
Yes.
Good. That's going to get distributed to the A. And that is going to get distributed with not only the A, but the B. So the answer here is going to be A to the 3rd, right? Because this here has an imaginary, I'm not going to say an invisible number. What's the number here that's inside the box?
1.
It's going to be a 1. So this is how I get 3 times 1 is 3. And B is going to be what? What's the value here for B?
6.
6. Do not add 3 plus 6. Why can't I add 3 plus 6?
Because it's not the same base.
That's right. It's not the same base. You better not make that mistake. Or else we're going to call on Go Power Rangers. Where's Megazord? Okay, cool. So let's work with some real ammunition here. Who watched Power Rangers where they were young? Nobody? Nobody watched Power Rangers. Really? Okay. I guess I'm dating myself. So cool. You did? Macintosh?
Yep.
No?
Zio. Zio.
Zio?
Yeah.
Oh, I don't remember Zio, but okay, cool. All right, ladies and gentlemen. You know, we're not going to always stay in the sandbox, right? So we got to show some real ammunition here. And we're going to test this out. This is what you're going to see on the exam. You see, everything that we just went over is here. And I'm going to show you what you need to do here for this. So let's write it again so it's easily understood. And I want you to start grouping. when you group things, they become easily seen. Are you going to combine the A and the B, or are you going to keep them together? What are you going to do? Anybody? What you gonna do?
You're not gonna keep them together because the bases are different.
Well, you want to keep the same base, right?
You said A and B. Those are
Don't
two
combine
different.
A and B.
Yeah.
You want to keep A with A and B with B, right? And 3 is a constant. So you want to keep 3 by itself. What is underneath that 3? What's over here?
1.
Yeah. So this is something you got to keep in mind, okay? So I'm going to take it out. Those 3 over 1. I have A negative 3 over A squared. I have B squared over B to the 4th. You see how I took them out? And remember, don't forget, there's a 2 outside. That's your Power Ranger. That's your Megazord, the number 2. And you're going to leave that guy for last. Because when is Megazord called for in a battle? At the end, right? You don't want to mess with the Power Ranger Megazord. So, 3 over 1 is what?
Tree.
Tree. Yes, I agree. What is A to the negative 3rd over A squared? Remember, there's a negative here. This represents a negative. So this is going to look something like this. A negative 3 minus 2. So what do you think I'm going to get there?
-5.
I'm going to get a negative 5. So I have 3A to the negative 5. The next one. B to the 2nd power. Right? There's a negative here. Right? So that's a negative there. And then what is that? That's the number 4, right? So this is going to be B to the what?
-2.
Yes. What is outside here? Is a 2, right?
2.
2.
That's my Power Ranger. Go, go, Power Ranger. Call my Megazord. So I'm going to distribute that 2 to the 3, the 2 to the negative 5, and the 2 to the negative 2. Right? So what do you think my answer is going to be? Well, this is going to be 3 squared A to the negative 10. Negative 5 and 2, when I multiply, is 10, but it's negative. And B to the negative 4. Is that my final answer? No. This is going to become 9. Correct?
Yes.
And this is going to get the reciprocal, which is 1 over A to the 10. Good. This is going to be 1 over B to the 4th. And remember, this is multiplication, correct? So in the numerator, I am going to get what? What am I going to get in the numerator? 9 over A to the 10th, B to the 4th. Let's say this is worth 10 points on the test. And you get here. Actually, no, you get here. This is going to be 8 points. If you get here, you're going to get 10 points. When I grade your papers, if you get to this point, you get 8 points out of 10. You lose 2 points. But if you get to the final part, you get full points. Are we good?
Yes.
All right. La 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 la. Ba-da-ba-ba. All right, cool. Let's keep going. All right, so this time you're going to help me do this because I can't be doing all the problems. I'm going to be calling on people now. So if you're pretending not to be here, all right. So Grant, Jamon Grant, are you here? Da, 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 da. Not here. Job Davian.
Yeah, I'm here.
Yeah. Don't sound so excited, man. It's only 7:42 Friday night. Job, what do I got to do? What's the first thing? You want a group? What are you going to do?
You're grouping the A's and the B's. And then is that an 18?
Yes, sir.
Yeah, and then you group the A's and the B's.
Very good. That's all I'm asking from you. Thank you. Sophia Guzman. Are you here? Do. Not here. Gabriel Townsend. Gabriel Townsend. Are you here? Nope. Alrighty. Mazriha.
Well, what I did was I wrote them again separately.
Okay.
And then I did, well, 18 over 6, I just left it like that. I just wrote them separately. And then for my exponents, I did my exponents first, which was since there's no exponent for the b on the decimal, I just left it as -6. And then for my a's, I put 4 subtract parentheses 2.
What about 18 over 6?
18 over 6, I left it. Well, I mean, I didn't get to that part yet. I was doing that.
No
I was
problem,
doing
problem. Thank you so much for helping me out. I appreciate it.
Yeah, you're good.
Jalen Hall. What do I got to do with the 18 over 6?
Do you divide it?
Yeah.
Is it 3?
Yeah.
It's 3.
Yeah. Pretty
I'm
cool.
up to the part where you subtract the exponents.
Good.
I didn't subtract them yet though.
Ladies and germs. Dacia Harris. Are you here? Dacia or Deja or how you say your name?
I'm here, but I'm confused. That's why I'm just tagging along right now. I don't know what I'm supposed to do next.
No problem. This is why you're here.
I'm here though. I'm right here.
You are at the party. You are in the VIP room with all of us chilling. We're all having a good time and we're cracking jokes, you know? So 4 came from here, right? Yeah.
Yes.
And then this negative sign right here in the middle is coming from the division sign. That's a negative.
Okay.
So that comes here. And then this -2 here is this -2 in the parentheses, okay? So I hope you're not lost there. Now, a negative and a negative is what?
Positive.
It's a positive. So if I have a negative and a negative, and that's going to become a positive, then this is a to the 4th plus 2. And that becomes a to the 6th. Are we clear on that? Now, the reason why it's a negative and a negative is because the negative is in the denominator. Does B have a negative in the denominator? No. And because of that, then it's not a negative and a negative, it's a negative and a positive become a negative. So now here we are adding. So since we're not changing the signs there, this is going to become what? This is going to become b to the negative 7. And then I bring this down and I have a 3. So I have my final answer here, but it's not finalized, right? Because I got to do some more stuff to it. So I have 3a to the 6, b to the negative 7. Can I do something with that negative 7? Can I write this as 3a to the 6 times 1 over b to the 7? Yes.
Yeah.
So then this is going to become 3a6 over b to the 7th. Because this whole thing times 1 is itself back, right? So this would be my final answer. This is section 1.2, chapter 1. Okay? All right, let's keep going. Let's keep going because you guys are going to be able to go on the video. Megazord. All right. Let's keep talking. All right, cool. This is going to now bring us to section, we're still in chapter 1. And now we are in section 1.3. So let me share in the book because I always do show and tell. Show and tell. Do, 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 do. Do, 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 do. Okay, enough of Mega Sword. Why is this not populating? Okay, good. You guys should see it, right? All right, good. So you guys see that? We're not doing Mega Sword. Yeah. Da, 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 da. Okay, cool. So now we're going to go to section 1.3, radicals and rational exponents. And I want you to take a look at this right here, evaluating square roots. It's very important that you look at this. All right. So this is where I'm at now. I'm going to go back to my iPad. So you know where I'm at. And we're back to the iPad. All right. So chapter 1, section 1.3 talks about radicals. And we touched on it on section 1.1 a moment ago. This is a radical sign. Let me label it. Radical sign. Next, inside the radical sign is called the radicand. Okay. Next. The book doesn't get into this, but I want you to know this. This is called the index. And here, on top of the this is a variable, by the way. This is a power in the green. We could also call this here a base. All right. So you have different pieces to this. Okay. This whole thing here, let's pick a different color. in orange is called a radical expression. So we have the radical sign, we have the radicand, which is inside the radical sign, and inside the radicand, we have a base and a power. Outside of the radical sign, in that box to the left, we call that an index. It's important to know these values because later on, we're going to use all of them. All right. Now, let's do some easy stuff. Because we do easy and then we do hard. You have the square root of 25. What do you think the answer is?
5.
5.
It's not only 5, it's negative positive 5. Because the radical sign outside has a positive and a negative. Now, when you communicate with people, do you tell them, I'm negative 5 blocks away from you, or I'm like negative 5 miles from you? Do you say that?
Nah.
Absolutely not. You're like, yo, I'm like 5 miles away. I'm like 5 minutes away, right? Or I'm 5 blocks from you, right? All right, cool. Next. This is what we call a perfect square. And we know it's a perfect square because perfect squares are, for instance, 1, positive, negative 1, because this is going to give us positive, negative 1. Square root of 4, positive, negative. This is going to give us positive, negative what?
2.
9. What is this going to give us?
3.
3.
And we're going to have 4, 5, 6, 7, 8, 9, 10, 11, and 12. Square root of 16, square root of 25, square root of 36, square root of 49, square root of 64, square root of 81, square root of 100, square root of 121, square root of 144. Right? Aren't these perfect squares?
Yes.
You better believe it. And you need to know these perfect squares because they make your life so much simpler, especially later on when we have complicated equations, right? Since they're perfect squares, you're going to get a whole number. Whoopee! Wonderful. That's amazing. We got a wonderful whole number. Blah, 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 right? But what happens when it's not so wonderful? What happens when it's not a perfect square? Well, we have a rule, right? We can break that value, whatever this is, into 2. And you want to always try to look for a perfect square. I'll give you an example. Square root of 12. What is 12 divisible by? What goes into 12?
And 2.
1, 2, 3, 4, 6. What's the next number? Does 8 go into 12?
12.
9,
12.
10, 11, 12. Now, if I break this down and I go 6, 2, I know if I multiply these together, I'm going to get square root of 12, correct?
Yeah.
Yes.
But that doesn't help me break it down. I want to know from this list, do I have a perfect square? Do I have a perfect square? Yeah, I do. It could be square root of 1 times square root of 12, but then I'm back in the same boat, right? I don't want to be like that. So I could be like square root of 4 times square root of 3 is equal to square root of 12, right? So that looks kind of cool because here I could get positive negative 2, bring this down. This is tied by multiplication and I get square root of 3, right? So my final answer, if I have square root of 12, this could become what? Positive negative 2 square root of 3, right? Does everyone know how I got this? Because I have a perfect square, which is 4. I know I could have used 1. I know I could use 2. I know I could use 3. Actually, no, not 3. I know I could use 6 and 12. But what I truly want to use is a perfect square, if it is possible. Does everyone understand that? Are we good with that? No, not good? Maybe?
No, not really. I'm still a little confused.
Where did I lose you? With the perfect square or with the square root of 12?
Like, I don't know how 4 is a perfect square and then how you like did all of that.
So a perfect square.
Like what makes, yeah. Okay.
So do you agree that all of these are perfect squares?
That's what I'm saying. I don't know what a perfect square is. I wouldn't
So a
know.
perfect square is a number that if I use a calculator, I am not going to get a decimal value, but a whole number. So the list that I gave you are the first 12 perfect squares. This is something you should memorize. Something that you want to know off the back of your head for the exam. So a perfect square, for instance, the square root of 1, I got a positive negative 1. The same thing with 4 and 9. But when I don't have any of these first 12 perfect squares, is square root of 12 a perfect square? Do you see it on the list?
No.
No. Since it's not on the list, then you can then say to yourself, you know what? This is not a perfect square. Because square root of 12 should be around here, right?
Oh, okay, so we're going based off of the list. Everything on this list is like a perfect.
Good, good.
Okay.
No, I'm glad you're asking the question. So square root of 9 is a perfect square, but then the next one after that is square root of 16. Where does square root of 12 lie? Well, it's not a perfect square. Since it's not a perfect square, I have to break this into two values. You see the two values, the one on the left and the one on the right? But
Yes.
before I determine that, I have to say to myself, well, what goes into 12? 12, well, 1, 2, 3, 4, 6, and 12. These are values that go into 12. But out of these values, which is a perfect square? Well, it's going to be 4, right? Because that matches this 4, right?
Mm-hmm.
So I'm going to use 4 here. And then what is 12 divided by 4? It's 3, right? Because what number times 4 will give me 12? It has to be 3, right? So here, if I take the square root of 4, this is going to give me a positive negative 2. And this is my final answer. Because I cannot break 3 and 1. There's nothing that will give me a perfect square. Well, the only thing that I'll get is square root of 1 times square root of 3. But then the square root of 1 is 1 times square root of 3. But then that's going to give me myself back, right? So why am I going to go through all of this trouble and come back to where I started? So I know that I can't go any further besides square root of 3. Because there's no other perfect square besides 1. And a perfect square of 1 is going to give me myself back. So why go through that trouble of going through all of that, right? So just remember, you want to look at these first 12 values to find a perfect square. Now, you know it's not going to be this easy, right? This gets a little bit more involved. You know that, right? So We're going to do that right now. So let's say I have 5 square root of 12 plus 2 square root of 3. Now, let's talk about some things that we need to understand before we touch this. Look at the radicands. The radicand here is a 12, and the radicand on the right is a 3. Are they the same?
No.
No, they are not. Because they're not the same, I need to say to myself, what can I do to make him look similar? So remember the example we just did up here? What do you think I got to do with that 12?
Can you break it down?
You got to break it down. So what are the two values that we came up with before to break up that square root of 12?
4 and 3.
Yeah. 4 and 3. Now, you see that I am now creating something that is constant here, right? Do you see that? You see the square root of 3?
Yes.
Look at this addition sign as something that is separating the left and the right. So now on the left, what can I do with this 4? What do you think I could do here?
2.
I could get a 2. So then this is going to become positive, negative, square root of 2, and square root of 3, right?
3.
Now, the 5 is feeling lonely. The 5 is like, yo, what's up? You guys left me alone. What are we going to do here? You know, it's like, ¿qué pasa contigo? You no love from me? What's wrong with number 5? The 5 comes down. You see the 5 is coming down? Now, we are going to keep a positive value. Because when we do negatives, it gets complicated. Even though we know there's a positive and a negative 2, we want to keep it positive. So what is 5 times 2?
10.
This is going to become a 10. Square root of 3. Now remember, there's an addition sign here, right? You see the addition sign?
Yes.
Can I do anything with this 2 square root of 3 on the right? Can I break it down any further?
No.
Absolutely not. I cannot do anything. Now, this is where I lose a lot of people. Do I have the same radical sign?
Yep.
Since I have the same radical sign, I'm going to bring the radical sign down. Do I have a value that now I can add to each other? Which is
12.
the, I'm trying to pick a color that's good, blue. 10 and 2. Can I add these together?
Yeah.
I sure can. This is going to become 12, and I keep my radical 3. So let's do that again. If I have 5 square root of 12 plus 2 square root of 3, my goal is to have the same radical sign. I break these down. Square root of 4 times square root of 3 plus 2 square root of 3. The 4 becomes a 2. This 5 comes down. This is multiplied. This becomes a 10 square root of 3. This comes down. That's a positive, and I have 2 square root of 3. Since I now have the same radical, I am able to then only add the 10 and the 2 in the green. These two get added. They become 12. And I keep the square root of 3. This is my answer. You need to practice this because you will see problems like this for the exam on Wednesday. So concentrate on a problem like this and you'll be fine. All right, let's keep moving. This is section 1.3 of the book. Let me bring it over here. Where is my guide? All right, so you guys did that. All right. All right, that brings us to our next example in chapter 1, section 1.3, which is rationalize the denominator. So when we are rationalizing the denominator, let me explain to you what that means. Trying to get the example. Okay, good. We all know what a fraction is, right?
Mm-hmm.
When you have a fraction and in the denominator you have a radical sign, this is not halal and this is not kosher. That means you cannot eat it. It's not good. You need to put it in an expression that is acceptable. Since we have the square root of 2, we are going to rationalize the denominator. What that means is we're going to take the denominator and we're going to create a fraction with it that has the same value. That same value is itself. So I take the square root of 2 and I create a fraction with it. The same value for the numerator and the denominator. What am I going to do with it? I am going to multiply 5 times radical 2. That's going to be 5 radical 2. And what is square root of 2 times square root of 2?
Is that minus 12?
That's going to be radical 4, right? Correct?
Yeah.
Yes.
But wait a minute. Didn't the professor say you cannot have a radical in the denominator? This is a bunch of malarkey, right? What's wrong with this man? Well, look at that radical. Is it a perfect square?
Yeah.
Yep. That is going to become positive 2 in the denominator. And my numerator is 5 square root of 2. This is good. This is very good. And this is how it should be. So now you're going to help me do another one. This one you're going to do with me. You're going to help me out. What do you think I got to do here?
Break down the 10.
Okay. I agree. So now what do I got to do? Oops. I did this wrong. Hold on. I'm getting tired now. Momento, por favor. Getting super tired. Like, losing my mind now. The radical 10. Yes. What do I do now?
You gotta find the two numbers.
I'm going to multiply these. Just like on the top. So what do I get? In the numerator, I get 2 radical 3 times radical 10. And then in the denominator, I get 3 radical 100. Correct?
Yeah.
In the top, I also then become 2 radical 30 over 3 times 10. Do you see how that radical 100 became 10?
Yeah,
You see that?
it's a perfect square.
Hold on. Yeah, good for you. Oh, you speaking my language. I love it. So now, what is 3 times 10?
30.
30. Now, am I able to divide these or am I able to divide these? Can I divide the radical 30 with a 30 that doesn't have a radical?
No, just the 2 and
No,
the 30.
no, I cannot. So I'm only going to do the one in the blue. So 2 goes into 2 how many times?
Once.
Right. And 2 goes into 30 how many times?
15.
And what remains? Radical 30, right? So this is radical 30 over 15. Can I divide radical 30 by 15? Yes or no?
No.
No.
Absolutely not. Cannot do that. Let's keep going. So we just did examples of rationalizing the denominator. Now, this rationalizing of the denominator only had one expression, right? How many values are here in the denominator? It's just by itself, right? The radical 2, correct?
Yep.
Now, we're going to talk about something that is not by itself. It's radical 5 plus 1. Here, the radical is not alone. Is it alone?
No.
But it has company. It has baggage, right? It has the positive 1. We still have to rationalize the denominator. So we're going to do that. But because there's a 1, I have to use the conjugate. So this is rationalizing the denominator. And using the conjugate. So now, what does the conjugate mean? Well, the conjugate means that I am going to take the opposite value of this number. What is the opposite value of that number?
-1.
That's right. Now, let me put this over here in the bottom because this is going to become a hot mess. Take a look at what I'm going to do here. This multiplies with the square root of 5. This multiplies with the -1. What is 3 times 5?
15.
15.
What is the square root of 3 times itself, but it's a negative?
-9.
Negative square root of 3, right? Because I'm a positive square root of 3 times a -1, I'm going to get myself back, but it's going to be negative, correct? Now, I'm going to go slow here. What is square root of 5 times square root of 5? Then I have to multiply times -1. So what am I going to put in the denominator first? What's square root of 5 times square root of 5? What's 5 times 5?
25.
What is square root of 5 times 1, but there's a negative?
-5.
Negative square root of 5. You got it? I'm not done. What is +1 times square root of 5, then times -1? So what is 1 times square root of 5? What is anything times itself?
Itself.
Itself back when it's 1, right? So it's going to be positive square root of 5. What is 1 times -1? A
-1.
positive times a -1.
-1.
It's going to be -1. Now I got this. Do I have common terms? Can I cancel these? Can I cancel? Oh boy. Can I cancel these right here? I have a negative square root of 5 and a positive square root of 5. Can they just go?
Yes. Yeah.
Yeah, they could go bye-bye. So now I have a numerator of 15 minus square root of 3. And I have square root of 25 minus 1. Is the square root of 25 a perfect square?
Yeah.
So that becomes +5, and I have a -1. So this final answer is square root of 15 minus square root of 3 over 4. This is my final answer. That is what you are expected to do on Wednesday's exam. Let's do another one. And this one, you're going to do it. Well, you're going to tell me what to do, and then we're going to do it. So we got square root of 5 over square root of 3 minus 1. Is this kosher and halal?
No.
No, it is not. What do I have to do?
You take the square root of 3 and then you put as numerator and denominator. And I think I'm pretty sure you also take the -1 as well.
And we're doing the conjugate. The conjugate means that we take
+1.
+1. Right. Don't forget that. Next, what do I got to do? What comes next?
Distribute.
Yeah. So, what do I have as my numerator? What is square root of 5 times square root of 3?
15. Square root of 15.
So I got square root of 15. What is square root of 5 times +1?
Square root of 5.
Positive square root of 5. All right, now let's talk about the bottom. I have negative square root of 3. What am I going to do with this negative square root of 3?
Times it to 1. Times it by 1.
I'm going to times it but before I times it times 1, what is before 1?
The
3.
square root of 3.
Square
Yeah.
root
So
of
what
3.
is square root of 3 times square root of 3?
9, square root of 9.
9.
Yeah. Then I'm going to get what? Positive square root of 3, right? When I multiply times the 1, right? So I did this first. Now I did that second. Next, I got to do what? Who am I doing next?
The negative
The
1.
negative
Negative
1.
Negative 1 times the square root of 3. Then times, this comes first and this comes second, right? So what is that? What is negative 1 times square root of 3?
Would be square root negative
negative
3.
square root of 3.
Yeah. What is negative 1 times positive 1?
Negative 1.
Negative 1. Can I cancel these in the middle?
Yes.
Yeah.
Bye-bye. See you later. Enjoy. It was nice knowing you. Next. So I have in the denominator square root of 9 minus 1. And in the numerator, I have square root of 15 plus square root of 5. Woo. Can I do anything with the numerator? Nope, I cannot. Can I do anything with the denominator?
Yes.
What is the square root of 9?
3.
3.
3 minus 1 is what?
2.
2.
Good. This is my final answer. All righty, let's keep going. You got plenty to study over the weekend. Let's keep going. Where are we? All right, this is what we're gonna do. We're gonna take a 10-minute break because what comes now, moving forward, is not hard, but it is involved. So this is gonna be section 1.4, chapter 1. And we're going to bring in polynomials. So I'm going to stop the recording now. We're going to take a little break. All right, so resuming recording. I was mentioning earlier that we did section 1.1, 1.2, 1.3. We're touching on 1.4 now. The goal tonight would be to reach 1.6 or try to reach as much as we can in this chapter because that way you have something to study out. So right now we're going to focus on 1.4 on polynomials, right? And we're going to get into what a polynomial is. And now I'm going to go back to my iPad. Okay. All right. So everybody can see my iPad, I hope. I hope you can. 1 second. Just gotta size this up. For some reason this thing is not working. Doesn't want to go there. Okay, cool. All right, so let's talk about polynomials. Polynomials. So before we get into poly, we need to understand what a monomial is. So let's talk about a monomial. A monomial is going to have a variable. This variable is known as x. The variable x is going to have a power. And it's also going to have a coefficient. Now, when we have a monomial such as x to the second power, then in front of it, we said we have what? What's in front of the variable?
Coefficient.
The coefficient. And this value, if it's not there, is going to be a 1. But sometimes it is there. And they give you, let's say, 2 to the x to the third. So here, this is a monomial that has a power of 3, has a coefficient of 2, and it has a variable of x. This is what we call a monomial. Now, if I have x squared, right, plus, let's see if I have an example for you. X squared. X squared. Let me go here and delete this. Minus 5x. Is this considered a monomial? Would you say this is considered one single term, one single entity?
No.
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 Because I have one monomial. This is one monomial. And I have another monomial. All right, let's turn that blue. So I have another monomial. If I have two of the same thing, we don't call this two monomials. We call this a binomial. Binomial. And we see this in real life, right? We call bipartisan. Bipartisan means that you have the Democrats and the Republicans when they're making laws, and the congressmen, the senators, they get together from different parties and they say on Fox News, on CNN, on the news and the outlets, they say, well, this law that is going to pass has bipartisan support. Bipartisan, meaning two, always two, bi. Okay, by frequency, two frequencies, right? So binomial means two monomials, right? This means two monomials. Now, I'm going to tell you a little secret. A binomial is also known as a polynomial. If you have two monomials, which is one binomial, that one binomial is the same thing as a polynomial. So how many monomials do you need to have a polynomial?
2.
That's it. Now, let's continue with this idea. X squared minus 5x plus, not plus, minus 14. How many monomials do I have?
2.
Look at the colors. I have a monomial here. I have a monomial here. And I have another monomial here. How many monomials do I have? Do I have 2?
3.
I have 3. This is not this is not a binomial. This is called a trinomial. How many monomials do you need to have a polynomial?
2 or more.
So this is a polynomial. Okay? These are the fundamental basics of algebra. Please know them, understand them, And you need to have the same base in order to add them and subtract them. If you don't have the same base, you cannot speak. All right? It's like, si yo empiezo a hablar español en estos momentos, muchas personas que no hablan español, no, o los de inglés no van a entender, pero los de español sí. Y los de inglés van a decir, este hombre está loco, ¿qué está hablando? Right? So those of you who don't speak Spanish, you're like, what just happened? What happened here? ¿Qué pasa aquí? ¿Qué pasa contigo? Right? No good. All right, so let's talk about operations. Excuse me. Excuse me. Good thing no one is contagious over Zoom. I was just allergic to something. So what kind of operations do we have? Well, we have addition, right? We have subtraction. Okay. What other ones do we have?
Multiplication and division.
There's it. It sounds simple, but it's not. Each of these has its own rules. All right. So let's look at some examples about how do we add, subtract polynomials. Let's do some. Let's do some. Now, when we do operations, there is something that here in America they teach. When I say America, the United States, right? Because America includes North America, Central America, and South America. So let's be clear, right? So this is called PEMDAS. So this is parentheses, exponents, multiplication, division, hold on, parentheses, exponent, multiplication, division. What do I feel like I'm missing something? I'm drawing a blank. Arithmetic, addition, and subtraction. That's what happens when you keep teaching straight. You forget what the acronyms are. All right, so we got parentheses, exponents, multiplication, division, addition, and subtraction. Not only do you have to follow this order, right? This is the order. You also have to do things left to right. Unless the parentheses is to the right. We'll do some examples. All right. So now that you have that, let's do some problems. Okay, cool. So we have 6x squared minus x plus 9 plus negative 4x squared plus 3x minus 7. What kind of polynomial is this on the left and the right? How many monomials?
Trinomials.
It's a trinomial. This is a trinomial. Okay. Now, let us look at what is happening here. 6x squared. Does the 6x squared relate to the negative 7 on the right or the positive 3x?
No.
Which one?
Negative 4x squared.
That's right. That's right. You are correct. Ding, 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 ding. That's good. I'm looking for my flag, but I don't have my flag here. Very good. What about the negative x? Am I going to be looking at the -7?
You're gonna
No.
look at 3x.
I'm going to look at the
3x. Yeah.
That's right. And last but not least, I am going to look at the constant. You see the word I'm using? Constant, which is +9. Not because it's +9, because the -7 is also a constant. Okay? So now I have these. That is the first thing you have to look at when you see this. It's like shopping, right? You going to the mall, you look at the, what is that called? Window shopping, right? You look at the window in the store. You're like, this looks interesting. Or maybe you're like, I don't like this. This doesn't relate to me. So I'm not going in there because I'm not into video games and that's not the store that I want to go into. Or maybe it's a nice store and you're like, wow, they have some nice clothing up in here. So you're analyzing, right? You're analyzing. So this is what we just did. We analyzed the bases, right? X squared goes with the x squared. X to the first power goes with x to the first power, right? We're grouping them. After you group them and you see what you have, then you have to look at the signs. So now, let's change colors here. Blue. Look at what's in the middle. What's in the middle here? What operation is this?
Addition.
Addition.
That's right. This addition sign is going to talk to all of them. And it's going to say to each one, a positive and a negative is up. The first one is going to be a negative, right? 4x squared. Next, a positive and a positive is what? That's a positive.
Positive.
A positive and a negative is a negative. Whenever you have a positive, whenever you have addition here, nothing changes with the second term. Nothing changes with the second term. Let's all remember that. When I have a positive, nothing changes with the second term. So it's going to be easy, right? 6x squared minus x plus 9, right? And now I'm going to group this stuff. I'm going to group it. I'm going to write 6x squared minus 4x squared, right? Then I'm going to have the one in the green. I'm going to have negative x over positive 3x, right? That's the next one. The last one is the one in the purple, positive 9, negative 7, right? So now I'm going to do the math, right? So 6 minus 4 is 2. Now, x squared is the constant, correct? I shouldn't say constant. X squared is the base. Did my bases change? No, it's just the base.
No.
So no, we're not doing anything here. So just keep it.
X squared.
Good. Next, I remember there's a 1 here, right? There's a 1 here. An invisible one. If I have $3, right? Here's my wallet. You see my wallet? Let's pretend I have $3 in here. And I give $1 away. How much do I have left?
2.
Positive 2x. Positive 2x. And then the last one is easy. 9 minus 7 is?
2.
2. So my final answer is 2x squared plus 2x plus 2. This is the answer for when I am adding two trinomials. This would be my answer, right? This would be my answer. Now, let me ask you a trick question. Can I combine these?
No.
Why not?
Because of the exponent?
Because the exponents are different. You see the power here? This is a 2. This is a 1. Cannot do anything like that. Okay? So just be careful. And then this is 2 times 1 to the 0 is 1. So that doesn't happen there. All right. Now let's do another one. But this one is different. This is subtraction. I just got to make sure. Am I recording? Yeah, I'm recording. 4x to the third minus 5x squared plus 2x minus 8 parentheses minus parentheses 2x to the third plus x squared minus 4x plus 3 parentheses. Okay, ladies and gentlemen, I'm going to the mall. What is the first thing I'm doing? What is the first thing I have to analyze? I said it before. Is this a polynomial?
Yes.
Yes.
It is. How many monomials does it have?
4.
4.
4. Has 4 monomials. Okay. What is the next thing I have to do after I've identified that this is a polynomial that has 4 monomials on the left and 4 monomials on the right? What is the next thing?
Figure out what
Combinar.
goes with what.
I have subtraction here, correct?
Yeah.
Subtraction is not the same as?
Addition.
No. Subtraction changes people, right? Subtraction says, okay, what is the sign for the 2x to the third? What sign does that have? Inside. This is a parentheses. This has a positive 2x, right? This is a positive x squared. This is a negative 4. This is a positive 3. But what's going to happen here? Look. What is going to happen here? What is happening here? What is happening here? What happens when you start messing around with the wrong people that do drugs, that are criminals, that don't do no good? You hang with wrong people, what's going to happen to you eventually? You're going to become like them, negative, right? So there's that saying, tell me who your friends are and I can tell you what's going to happen to you, right? So the same thing is here with these negatives, right? What happens if you're a positive here with this negative? What's going to happen?
You're gonna
You're going to become a negative. Negative what? Negative 2x to the third.
Third power.
What's going to happen with the next positive? That's also going to become a negative.
Negative x squared.
Hell yeah. And what's going to happen with that 4x?
Positive 4x.
A negative and a negative is a positive. That's a cool thing about math, right? A negative and a negative become positive. So that's cool. That's cool. I like that. Positive. Positive what? Positive 4x. A negative and a positive is up.
Negative 3.
Negative 3. All right. Now, you already distributed the negative. Do not distribute again. Full stop. I bring down the 4x to the third minus 5x squared plus 2x minus 8. I stop. I keep going forward. And now I start grouping. You see the pretty colors? Don't forget them. 4x to the third minus 2x to the third. Boom. Next, minus 5x squared. No, Mazriha. We already changed the signs. Remember, we distributed. You see the signs change for all of them? Good. Okay, good question. Negative 5x squared minus x squared over. Next, 2x plus 4x. Boom. Negative 8 minus 3. Bam. Now that we have this in this format, it is easier to do. Now, you don't have to do it this way. You could do it your way and get the same answer, and I'm fine with that. But I just need you to know I need the final answer. So you see that these have the same, look at that, same base. You see it? Don't they look pretty? It looks so beautiful. Look at that. Oh, it's just wonderful. So now 4 minus 2 is what?
2.
2x to the third. I have a negative 5. I owe somebody $5. And I say, you know what? Can you give me another $1? How much do I still owe them?
Negative 6.
Yeah. 2 plus 4, ladies and germs.
6.
I owe somebody $8. And then I say, hey, can you give me another $3? How much do I owe them?
11.
Negative 11. So what is my final answer? My final answer is 2x to the third minus 6x squared
6x
plus 6x minus 11. Ladies and gentlemen, just like I know my 2 grandmothers are dead, you are going to have this problem on your test. God bless them. Beautiful ladies, my grandmothers. All right, let's keep going. Let's see, do we have another problem? All right, this is good. We're moving on. We're moving on. Let's go. Let's go. Let's go. Let's go. So we did that. Those are the polynomials. We did that. Adding and subtraction. Oh. That leads us to the next topic. That leads us to the next topic. So we did adding and subtraction. So now we got to do multiplication. Okay. So let's do multiplication. Multiplication. I like to start off with showing examples of how monomials grow and become bigger. And one of the cool examples of that is distribution. Okay? It's very important that we understand distribution. Okay. So I have X. Correct? What's my degree? What's my degree here? What's my coefficient here?
1.
Yeah. 1 coefficient and 1 degree. So whenever you see an X, it's not just an X. It has a lot of baggage. It has a coefficient, right? It has a power. This is the variable, right? This whole thing here is a term. We can call this a monomial. We could call this an algebraic expression. Right? It has a lot of baggage. It has a lot of meaning here. Now, if I take this x and I pair it with another x, and you see what I just did there, right? I put a parentheses. What is the degree here for both of these?
1.
1. Didn't we just talk about bases and powers and what happens when we have the same base? What do we do with the powers?
You can combine them.
Not only combine them, we are adding them, correct?
Yep.
So x and
X
x
squared.
is going to give me x. 1 plus 1 is equal to x squared, correct?
Yes.
Very good, very good. Now, you know we do the easy stuff first, right? We do the easy stuff. What is x times x plus 1? What do you think we're going to do here?
You're gonna distribute the x to the x and the 1.
That's right. X times x is x squared, and x times x times 1 is what?
X.
Plus x. So I have x squared plus x, correct?
Yes.
This is multiplication of monomials. Right? Now, with and binomial, right? There's a which is the binomial?
Un término.
This, well, I shouldn't write it like that. This here is the binomial. And then this here is the monomial, right? You guys agree?
Yes.
Mono, bi. Mono times bi gives me another bi. X squared plus x. Who is lost here? Anybody? Okay.
Me.
Ooh, who that? Who that? Job. Is it
Yeah.
Job or Job?
It's with the first part. So like
This one here?
with the parentheses. No, down. Like with the multiplication. Yeah.
All right, so this is the first part that we do, right? We distribute x times x. And then the second part.
And then it became x squared.
Right. And how did it become x squared? Look at the first, look at what we did here. This has a 1, this has a 1. 1 plus 1 is 2, right? So it's the same thing that's happening here, right?
Okay.
So x times x, there's a 1 here, and there's a 1 here. So 1 and 1 is 2.
Okay. It makes sense. Thank you.
No problem. And then x times 1, the number 1 is like job times 1. What are you going to get? You're going to get job. X times 1 is x. You get yourself back. Are we good with that? X
Yeah, I get it.
squared plus x. All right, cool. Now, this is the simple stuff. Okay. Now let's introduce division. And let's look at the x squared plus x. Look at the first monomial. Look at the second monomial. What is common to the first monomial and it's common to the second monomial? And you want to look at the simplest thing. Is it going to be the x squared or is it going to be the x?
The x.
The x. dx. So now, we call this the greatest common factor. And a lot of people, when you're taking class, right, the teacher might say, well, what's the GCF? What is the GCF here? Well, GCF stands for greatest common factor. So what is common? What is the factor that is common to both?
The X.
The X. Good. So we rewrite the problem. We separate them. And we divide by the GCF. What is the GCF? It's X, right? You see it? So now, we're back to exponentials. Remember exponentials that we did an hour ago? What does this division sign tell us? What is this?
Negative.
This is subtraction, correct? So
Yes.
what? Yeah, exactly. So what is this? X to the second, right? This negative comes down here.
Minus.
Right? That's a minus, correct? And there's a 1 here, right? So what is 2? What is 2 minus 1?
1.
That's right. There's going to be 1. Forgot about it. Correct.
Cancel the X.
And then there's an addition sign here that comes down. All right, so that's an addition sign. So now, let's look at the tricky one. X divided by X. So now, I'm going to make this a little complicated because I need you to understand the math. Is there a 1 here? Yes.
Yep.
Is there a 1 here? Yes. And there's a subtraction sign, right? So this means it's x1, right? The 1 in the numerator. There's a subtraction sign here. And there's another 1 here, right? So what is 1 minus 1?
0.
What is anything to the 0 power?
1.
Exactly. This is going to give me 1. Since that's going to give me 1, I'm going to put that 1 here. So, x squared plus x using my greatest common factor, which in this case is x, is going to give me x. I used x to now have the answer of x plus 1. Did I get the same problem back? I started with that problem earlier. Look at it. Right there. I started with this problem, right? I said, guys, we're going to multiply. We're going to multiply x times x, x times 1, and I'm going to get x squared plus x. So I took 2 small things, and I put them together, and I ended up with x squared. That is what multiplication is, right? When people get married, right? One person, another person. What happens when they get married? They have children and they multiply. Well, this is the product of the children right here. X squared plus x. What is the opposite of marriage?
Divorce.
Nobody knows the opposite of marriage? It's divorce, right?
Divorce.
Divorce for division. Multiplication for marriage. Divorce for division. So now the family is going to break up. The x squared plus the x, they're going to break up. There has to be some type of commonality, right? That's why they go to court and they got their judges and they got their attorneys. And now we need to divide these people. Well, we got to find some common ground. Well, the common ground is the greatest common factor, which is x. So when we are doing division, we are extracting what is common to both out of them. And what is that? Well, in this case, it's x. And when we extract x, right, our greatest common factor, this is going to give us x to the first power, and I'm going to end up with a positive 1. And I am accounting for this because this is my greatest common factor. X is the greatest common factor for x squared plus x. All right, so now that is division. But wait, there's more. We got to do more. More. We can't just do that. So let's do division of rational expressions. What did we say is a rational expression? What did we say earlier today at the beginning of class? Do you recall what is a rational?
Fractions.
Yeah. And now we're not doing rational numbers. We are doing what? What did I just call it? What was the name I used? It's a rational expression.
Rational expression.
So a rational expression is a fraction that has numbers and monomials. Ooh la la, so exotic, right? Escargot, right? I don't need escargot because those are snails. But it's all good. Some people do eat them. So let's do an expression here. And this is I skipped over section 1.5. I'll leave that for last. Section 1.6, chapter 1. So I skipped over section 1.5. I was at 1.4 when we did addition, subtraction, multiplication, and division. And now I am in section 1.6 of chapter 1. So let's do an example. Before I do this example, no. Let's do it differently. Un momento, por favor. Like they did in the World Cup. Let's do a little water break. But you guys don't go. You guys stay here. You got to stay here with me. There you go. Cool. So this is the problem we're going to do. All right, so guys, let's go back to elementary school. Remember elementary school? And you guys will be like, what? We're in college, man. What's wrong with you? When we have two fractions with different denominators, what do we got to do here? Can they talk to each other? Or is it like a situation where empiezo a hablar español y mucha de la gente que no habla español ahora no me entiende porque estoy hablando en español? Y lo mismo está pasando con esta fracción porque tenemos diferentes denominadores y no se hablan uno al otro y tenemos que tener un lenguaje universal. So what did I just say there, right? Like what's going on? Yeah. What happens when I got two fractions with different denominators? Job. No, because it's not. This sign here is not division. This sign is subtraction. We do change flip when we're doing division. Try and make them similar, says Mazreha.
Cross multiplication.
Yes. So what does 3 have that 4 doesn't? And what does 4 have that 3 doesn't? Common denominator, correct. So I'm going to use a 3 here, right? And on the other side, I'm going to use a 4. And the reason why I want to do that is because I want to end up with what? What is it that I want to end up with? A common denominator, right? So 3 times 5 is 15. 3 times 4 is 12. 3 times 4 is 12. And 2 times 4 is 8. Now, am I speaking the same language now? 15 over 12 minus 8 minus 12. Is that common?
Yes.
Me speaking English very good now? Yes? Good. Da, хорошо. You know, like the Russians. Amerikansky. We speak interneto. Okay, wonderful. 15 minus 8 is how much?
7.
7. Good. So I got 7 over 12. Was this hard?
No.
No.
I'm glad you say no. I introduce to you now rational expression. 5x over 4 minus 2x plus 3 over 3. It is the same problem. You see, 5 over 4, 5 over 4, 2 over 3. But now, something's a little strange here, like in Stranger Things in Netflix. Everything is turning upside down. What's happening here? What should I do? Do I speak the same language if I have different denominator?
No.
What must I do to make them speak the same language? Yeah?
Rationalize again.
No, we're not rationalizing. We don't have a square root. We have to find a common denominator. And what does the 3 have that the 4 need? And what does the 4 need that the 3 has? Or did I
Put
just say
4
that?
on both the numerator and denominator.
Correct. So this is 4 and 4, and this is 3 and 3. So now, ladies and germs, what is 3 times 5x?
15x.
15x over 12. Now, here's the tricky part. 4 times 2x. 4 times 3. What am I going to have here?
8x plus 12.
Yeah. What am I going to have in the denominator?
12.
Yeah. Now, do not rush here. What happens when people rush? I know a person that was rushing and they broke their ankle today. They break their bones. You don't want that. You got to take your time. If I have the same denominator, I keep the denominator. I have 15x here. What is happening with this negative? This is going to become negative 8x. And a negative and a positive is a negative.
Negative 12.
Negative 12. Now, are these the same terms? Do they have the same power?
Yes.
So if they have the same power, can I mix them?
Yeah.
Yeah.
Yes.
15x minus 8x is
7.
7x.
X.
minus 12 over 12. Now, let's speak on the following final answer. Can I divide these two numbers?
Yeah.
Yes.
I can? Why?
Because you can't do the 7. It has the X on it.
The 7x and the -2 are tied together. You cannot combine it or do nothing with that denominator. If you had, let's say, you had this. Can you cancel the 3 with the 3? Yes. That gives you 1. And can you cancel the 12 with the 3? That gives you 4, right? You could do that. That you could do. But whenever you have a monomial next to an operation of addition and subtraction, you cannot combine them with nothing else unless there's something common there. And there isn't. So be careful. Be mucho careful. You cannot. All right, let's keep going. Another example. We're going to go all the way to 10. All the way up. All the way up. We're going to do this. 3x plus 2 over 5. Because you got the whole weekend to party. Party, party, party. All right. So who's going to help me do this? Who should I call on? Hall, are you here?
Yeah, I'm here.
Yeah, she got a sweet voice. What's going on, Hall? What do we gotta do with the denominator?
You should multiply 5/5 on with the 2x minus 1/4, and then you could do 4/4 with the 3x plus 2/5, and then that would be 12x plus 6 over 20. Yeah.
Cool. Jada, I'm gonna mute you. Sophia Guzman, are you here? Sophia? Oh, you can't use the speaker? Okay. Sophia, what do I gotta do now? The mic. My mic isn't working. It's bad. Okay. So you can write on the text. What should I do here? I got 12x plus 8 minus 10x minus 5. You can write it on the text. Since your mic ain't working, how about your keyboard? We'll just wait 30 seconds for Sophia to answer. Nope. I'm not sure. I'm sorry. Okay, who's gonna help Sophia? We got Sophia down. This is like the army. We don't let no soldier down.
Oh,
You're
Who? What? Where? When? What?
You
Elena,
can use
yes.
what's up? What's up? What's up? What are we gonna do?
2x plus 3 over 20.
So we're gonna put 12x plus 8 minus 10x plus 5 over 20.
Yes.
Is that what you said?
Yes. Then we combine 12x.
Now, does everyone understand how this -5 became a +5?
Yes.
Are we clear on this? Because you don't want to make a careless mistake. That negative gets distributed. Negative gets distributed, right? Boom. Negative 10x. Boom. Positive 5x. All right, Elena, keep going.
You add, where you subtract 10x from the 12x.
That's right. 2x. What's
Then
next?
5.
Good. Anything else?
That's it.
That's it. We done. Well, we done with this problem, but we ain't done with class. Aha! All right, let's keep going. All right, very good, very good, very good. You guys are doing very good, very good, very good. I'm very proud of you, very proud of you. All right, let's keep going. Let's keep going. Ooh, shaka shaka, cha cha cha. All right, cool. Now that you did that, that brings us to our next division problem. 2x to the third plus 10x squared minus 6x over 2x. Ooh la la, this looks a little interesting. So we have a trinomial in the numerator, and we have a denominator with a monomial. Let me tell you how to break this down, or does anybody know how to do this? No? Okay. No problemo. Look at what we're going to do here. Ooh, this looks nice. This is beautiful. What's 2 divided by 2?
1.
I have 3 and I have a 1 here. What is 3 minus 1?
2. X squared.
Yeah. 10 divided by 2 is what?
5.
I got a 2 subtracted by a 1. What do I have here?
X.
To the first power. Now, I have 6 divided by 2.
3.
Whoa, 1 minute. 3. But I have a negative and a positive is a negative divided by a positive is a
Negative.
negative. Now, I have 1 minus 1. What's that going to give me?
0.
That's going to give me literally x to the 0, right? And x to the 0 is equal to 1.
Is 1.
And 3 times 1 is negative 3, right? So, what is my final answer? My final answer is x squared plus 5x minus 3.
Minus 3.
Guys, you need to know this. You see the problema? You're going to practice this. Yes, yes. Very good, very good. All right, let's keep going. This problem you're going to help me do right now. Let's do it. Let's do it. 4x to the third minus 8x squared plus 12x over 2x. How do I do this? Oh, tired, sitting down. Could have taken a flight to Miami. I would have been there by now. 3-hour flight.
4x to the third
Uh-huh.
over 2x.
Yeah. What's next?
You do
Over
that.
2x and 12x.
Yeah, very
Over
good.
2x.
Annette, she's on a roll. Good. So what's 4 divided by 2?
2.
What is 3 minus 1?
X squared.
X.
What is 8 divided by 2?
4.
A negative and a positive is all what?
A negative.
2 minus 1 is what?
X.
1.
12 divided by 2 is what?
6.
And x divided by x, this is 1 minus 1 is x to the 0. X to the 0 is 1. 6 times 1 is 6. So I get my final answer. This is it. Is this hard?
No.
No.
You need to practice. You will see this on the test. I'm actually looking at the test right now. How many questions is on the test?
10.
Good. I'm glad. I think Hall asked that earlier, right? That was a good question.
Yeah, I did.
Yeah, no, it's all good. It's all good. I'm just going over. Okay, we did a lot tonight. This is good. I'm so proud of you guys. This is so good. So we're only missing that and dots. All right, so I'm gonna leave factoring for later, but now I need to blow your minds before we end class. So we're going to do that now. All right, so let's do it. Okay. What are we going to do here right now? Yeah, I'm telling me.
Is that a -8?
Okay. Oh yeah, that is a negative. I'm sorry. The coffee is kicking in. This is how much coffee I drank tonight. I drank a liter of coffee right now. Oh. Hopefully I'm able to sleep. I'll probably have to like ride my bike before I go to bed to get tired. So tell me, what do I got to do here?
You would put all of the nomials over x.
Okay. So this is pretty good. So here I'm going to get what? What am I going to get? What's 2 minus 1?
7x.
Would we exit it first?
Now, hold on a minute. X over X, these can cancel out, right? Correct? I am left with -8. Here, I can't do anything. So I'm going to end up with positive 3x, right? Now, this looks crazy because we need to do this in a different way so you guys can understand. You saw how we did it here, right? And it was simple, right? This here is called long division. Long division is very similar to, let's say, 3 goes into 150, right? So 3, what do I have to put here, right? So it's 15 divided by 3 is 5, right? So I put a 5 here, and 3 times 5 is 15. So this is going to give me 0. And then I bring down the 0. So 0 divided by 3 is what? 0. So put a 0 there. And that's 0, right? So I know that 3 times 50 is 150, right? And you see the long division, right? On the right? Well, it's the same thing here on the left.
Okay.
So x squared divided by x is going to give you what? X, right?
X.
So I'm going to put an x here. Then x times x is going to give me x squared over parentheses, right? There's a negative here, right? I'm subtracting this. This is a positive, right? So a negative and a positive is a negative, correct?
Yep.
This cancels out. I bring down the -8x. So now this -8x Negative 8x gets divided by x.
X.
So then this cancels out. This becomes negative 8. What is negative 8 times x?
Negative 8.
Negative 8x. I have a negative outside. A negative and a negative is a
Positive.
This cancels out. I'm left with a 0. I bring down the 3. Right? This cancels out. Since this is a 0, my remainder, this is my remainder, is positive 3 over x. Because 3 divided by x, it's not divisible. So my final answer is x minus 8 remainder 3 over x. Which is the same thing I got over here, right? Where is it? Here. You see it?
Yes.
Now, there's a reason why I did this. Because the original problem was not x squared minus 8x plus, what is it that I gave you? The original problem was not x squared minus 8x plus 3 over x. It was x squared minus 8x plus 3 over x minus 2. This is the problem we need to resolve. All right, so let's do it. Can x squared minus 8x plus 3 over x minus 2 be broken down in x squared divided by x minus 2, negative 8x over x minus 2, positive 3 over x minus 2? Can we do this? Is that easy? No. It is not. This is why we have to use long division. And long division is not good because it's long. And because of that, it takes time to do. But remember what I said earlier. You're going to look at this value here. And that value is going to get divided by what? By this x. Right? So what am I going to get here? I'm going to get x, right? Because 2 minus 1 is x to the first power. So I'm going to put that here. Now I'm going to take this x and I'm going to multiply times this x and times the negative 2. So now what am I going to get? I'm going to get
X squared.
X squared minus 2x.
Minus 2x.
A negative and a positive is a negative. A negative and a negative is a positive. The x squares are going to cancel out. But now I have negative 8x and I have positive 2x. If I owe somebody $8 and I give them $2, how much do I still owe them?
$6.
I owe them $6. I bring down the 3. Now, I do the same thing I did with the x squared. I am looking at the negative 6x. Negative 6x divided by x is what? Oops.
Negative 6.
This cancels out, and I end up with negative 6. This negative 6 goes up here. Now I'm going to take that negative 6, and I'm going to multiply it times the x, and I'm going to multiply it times the negative 2. What is negative 6 times x?
Negative 6x.
What is negative 6 times negative 2?
12.
Now, I have a negative outside. A negative and a negative is a positive. A negative and a positive is a negative. So what's going to happen here? These are going to go bye-bye. Right? And I have 3 I have 3 minus 12. What is this?
-9.
-9. This is my remainder. So my answer is going to be x minus 6, remainder -9 over x minus 2. This is my remainder. This is my final answer. I need you guys to practice this because this is going to show up on exam 1. The only thing we have to go over for exam 2 on Monday. When is your exam again?
Wednesday.
The first exam is on Wednesday. So on Monday, because you got plenty to study over the weekend, on Monday, we're going to cover section 1.5, factoring. Right? And I need you to not only look at factoring, but I also need you to look at section 1.6 when it comes to division. So an example of the division that I am going to go over after factoring is a problem like this. But we're not going to do this tonight. We're going to do it on Monday. But I want you to learn how to do this problem over the weekend. We're going to go over it on Monday. One of you said earlier, change the sign and flip the fraction. So in this case, you change the sign and you flip the fraction. This is for Monday. Now that you do this, you have to now factor, which we're going to learn on Monday, and you could practice over the weekend. And this here is called the difference of squares, which we're going to learn on Monday. Today, we touched on this one, which this is the greatest common factor. So let's do that one since we touched on it. So the numerator here, what is common to both here? In the numerator.
3.
No. X. So it's going to be x is the greatest common factor. That goes into x squared x times. And then this is going to become 3. Because if I multiply this, I'm going to get what? I'm going to get x squared. And if I multiply x times -3, I'm going to get -3x. Right? So this part we can do because we learned that today, right? The fraction on the right. But on Monday, we're going to learn how to factor the numerator on the first fraction and the difference of squares. Jada, I'm coming to you. This is on section 1.5 of the book, chapter 1. This is what we're going to go over. So we got to learn about factoring. We're going to do a division problem like the one below. And that would be it. Jada, what happened? Where is she? Jada, you raised your hand. No, no more? Guys, do you have any questions for me?
No.
No.
All right. So the plan.
What is our homework?
The plan is for you this weekend. You see all of this?
Yes.
You need to be able to do all of this by yourself over the weekend.
Yes.
Because we did literally examples that are very similar to the exam. So focus on this that I did tonight. If you're able to do all of this, you will pass exam 1. I'm going to take attendance again before we leave because I know some people came late. The following people are absent. Natasha Signal, are you here? If you are here, say here. Annette Pena, are you here?
I'm here.
Yes. Alethea Harris, are you here? No, absent. Janelle Riggins, are you here? Absent. Ainul Rafsan, are you here? I thought I saw you. Yeah. Gabriel Townsend.
Does the homework need to be submitted?
No, no homework to be submitted. Study, study, study. Gabriel Townsend.
Here.
Absent. Oh, here. Thank you. Casey Ann Ricketts, are you here? Absent. Shaquan Simmons, are you here? Shaquan Simmons, are you here? Absent. I thought I saw you. Jashandeep Kaur. Jashandeep Kaur. No. All right. So I have 1, 2. Who's
I'm here too if you called my name.
Job. Where's Job? Job Davian. Yeah, you're here. I'm RJ here. There was somebody here. Harris. Desaya Harris. Daisia Abney Harris. Yes, I got you. All right, ladies and gentlemen, you got the whole weekend to study. You got the sections, you got the book. Oh, my phone number, in case you need to reach me. Text me first and tell me who you are, okay? That's my phone number. That's a Google number. So text me, say, this is so-and-so from your math class. This is what's up. This is what's going on. If you have any issues or anything like that. All right, guys. It's been a pleasure. Thank you so much. Good night.
Have a good night.
Good night.
Good
Thank
night.
you.
The video will be posted in 30 minutes.
Okay.
Good night. Anybody needs to speak to me? If not, bye-bye.
Bye.
Grant, are you here?
Good night, sir.
Actually, can I speak to you, please?
Yes, no problem. Grant, yeah, you're not on my list. Did you get an email saying that you're here? I mean, registered? Wow, they forgot to add you. Make sure you send an email. Grant, send an email. Hold on, I'll give you the email because I don't want you to take the class. I'm not saying that I don't want you to take the class. I want you to take the class, but I don't want you to take the class and not get credit for it. You know what I mean? That'll be wild. So yeah. Oops. There you go. That's the email if you ever need to speak to the program. Okay, Grant, you're good. Gabriel, you got to talk to me?
No, sir.
Okay, good night, Gabriel. Paul, you got to talk to me?
Yeah. I was just saying because I have work Monday to Friday, and I like my shift ends at 5:30. So I'm gonna be on the train. So if like I act up and my internet acts up, that's the reason. It's not like
No problem. So long as you make it to class, you see I take attendance at the end as well.
Okay.
And then you got the video, so anything you miss in the first 30 minutes, you'll be able to recoup it in the video. But attendance is mandatory, meaning that you do have to end up being in class. So it's good. Thank you for letting me know, Miss Hall.
You're welcome. Thank you. Have a good night.
No problemo. Rob-san, you gotta talk to me?
No, sir. Have a good night.
Okay, Rob-san. Good night.
Good night, sir.
Yes, not a problem.